In this application, we want to measure the height of the neck of this bottle. This is a color camera. We could get more accurate distance measurement if we used a grayscale camera. By having a color camera of the same resolution, we have a slightly lower resolution with color than with black and white. Regardless, let's show you these concepts that are still valid either way. I'm creating a caliper detector, and I'm going to rotate it by clicking and dragging on that arrow. And if I hold down the shift key, it'll move in 15-degree increments. That's a Windows thing. Now, I want to measure the height of the neck, like I said. With the color camera, we have 3 different color models, and we also have different software filters. We can look at red, green, blue, cyan, magenta, hue, saturation, value, L, A, B, and you'd use which one gives you the best contrast. We could also do color distance, or we could do a binarization. You can see the binarization really makes that contrast quite crisp. We'll leave it here to make it difficult to show how to do all kinds of applications with the caliper. Even on the grayscale cameras, you have all of these other tabs. The color channel is unique to the color camera. So first of all, we have here this transition. This one shows either way, either light to dark or dark to light. Next, on the distance, we can pick maximum, minimum, mean, or median. Going back to the probe, if we look at results, this shows graphs of each of the three different search stripes. And when we had picked maximum, what that means is which search stripe on the left will give me the maximum and which search stripe on the right will give me the maximum distance. So if we had picked minimum, it probably would have chosen this bottom search stripe instead of that top one. The other thing we can do is we have smoothing. You can see here this edge strength graph, and if we lower the number of pixels of smoothing, look at this peak right here. As I increase the smoothing, the peak starts to get sharper and sharper. And it's also, you notice this blue line gets longer and longer as I go 0, 1, 2, 3, 4, 5. Now it's getting shorter. So anyway, we know we only need to go 3 pixels of smoothing, because any higher than that and it starts getting worse. So let's put our edge strength at 8. I want to set the transition because it's my personal preference. It feels like it's going to be more robust. For the top, I want it to go dark to light, because up here we go from the dark down and we were looking for the light edge. Unfortunately, you can see this line on the lower moving because we really want that to be light to dark. So we have this other probe type that has separate arrowheads, and now I can set this one to dark to light and the other one the opposite way. So if I click and rotate holding shift, I can set this one here and I can set the other one down below. This says 3.1, we're detector 3, probe 1. I want to go dark to light as shown here, and for probe 2 I want to go light to dark. When we talk about the number of search stripes, if I make this 5, 6, when I come here to results, before we had 3 search stripes, now I've got 6 search stripes. Let me go back to 4, 2, only 2 search stripes. So that's what the search stripe parameter means. We have this other probe type that has 2 probes pointing in the same direction. Sometimes this is helpful. So here I'm going to keep the transition is going to be the same, dark to light, dark to light. But if I happen to have a better transition, a higher and more consistent contrast on that shoulder, if we're looking from the top down at this shoulder, it's black background against the white brightness of the bottle. If I'm going up though, I could have, you can see right here, it's a light gray to an equally light gray. So it just doesn't feel quite as robust. The final probe type we have is single-ended, and this just shows the number of pixels from the left edge. We can see here I have a distance of 150 pixels, so I can set my distance to 150 to 160 pixels, and it passes. So obviously if it deviates from that, then the detector will fail. This optimization tab just shows by default it's accurate. If you are tight on execution time, you could try a fast interpolation. Also to note, if we click on job and calibration, if we do a calibration, then this distance will be in engineering units, not in pixels. We have a one-click calibration with a calibration plate that you could print out the PDF version that comes with our software to actual size. Because we think in terms of millimeters and not pixels, you can always click scaling. If I put that the width of this thing is 30 millimeters, now I'm roughly millimeter. In this case, we're completely perpendicular to the bottle. If we always take a picture of every bottle from this same angle, the distance measurement is going to be repeatable. And now that we're dealing in 30 millimeters, when we set our range on our detector, it makes a little more sense. Make it 30 millimeters to 36 millimeters or whatever, but it's easier to set our distances because we get a better inherent feel of what distances we're talking about when we're dealing with engineering units instead of pixels.